digloid.com. In this screencast, I'm going to walk you through one of the more complicated, pages for how to get the best results from your digital camera. By the time you're done with this, you'll be able to understand how to have something equivalent to a 2 to 3 stop upgrade in the image quality of your camera just by doing two things. One is getting the exposure right, and the other is processing it correctly. Now, of course, I don't mean you're going to get that much every time, but most cameras are very poor at metering, having a film era algorithm to do it, which ties the ostensibly correct capture to the output, rather than saying let's expose for the benefit of the sensor the maximum possible highest quality image. They just don't do that, but you can as a photographer. So let's walk through this page and take a look. All right, so the first thing to consider is when you're out shooting, your camera is going to give you a histogram, something like this. This is a Sony histogram from the Sony a7R5. And as we can see here, it's at +0. So that's what the camera actually metered for the scene. And this is an artificial scene, but I see the same behavior all the time out in the field. Over on the histogram, the concept of exposed to the right means you want to push all of these as far to the right as you can without blowing something out. That is destroying detail. In this case, it looks like we have good ways to go on green, a little bit of ways to go on red, and quite a bit ways to go on blue. In fact, as we'll see, the green is most exposed and has good ways to go, and the red is grossly underexposed, and the blue is grossly underexposed. There's 5 frames here spanning 1 2/3 stops. This last one, the 1 2/3 stop, more exposure. See the +1.7 here. The more exposure one looks on the histogram like, oh boy, we just wiped that thing out. It also looks really bright. But as it turns out, this is actually an optimal exposure that will give you the very best quality you can get from this camera. How would you know that, though, given that the camera does a pretty poor job of this? Well, you need to reconcile what your camera gives you against what is actually in the files, and that's going to take some experience. Here, what we're looking at now is RawDigger. RawDigger is a program you can get, highly recommended. And what RawDigger does is shows you what's actually in the raw file. And here, there's actually 2 green channels, but I've set it up, it averages one of them. Here in the middle, so we've got a red, a green, and a blue. And the way to read this is you need to know the maximum value for your file. In the case of a Sony 14-bit file, that's around 16,000 over here for all of them. And then you look at where the values are distributed across this. And what you don't want to see is things piled up right here next to 16,000. But you also don't want to see this gap. You can see from 16,000 to 8,000, that's a full stop of headroom that's not being used at all. And in fact, it goes way over to this point here. And so this exposure, as metered by the camera, is actually at least a stop and a half too dark. In other words, the camera shot this like it's ISO 320 as far as the sensor is concerned. This is not a good exposure. You're going to get a lot more noise in some things like skies and smooth tones than you would if you properly exposed it. If we look at one more stop, 3 here means 3/3. You'll see that it's gotten a lot brighter. Here's 0, that's the metered. Here's 3/3, that's one more stop. You can see the whole thing just shifted one stop to the right. But the actual best exposure here is +5/3, 1 2/3 stop more. At that point, the blue is pushing pretty far over. The red is still a stop and a half low. From here to here, that's a stop and a half. The green, however, is shoved up against the right, and there's a little spike, but it's not actually blown out. And RawDigger will tell you that too. So this is actually the ideal optimal exposure to get the very best result from your camera. But the camera metered 1 2/3 stops lower. So it really cheated you of the quality you could have. So +5/3 is what we want, and that's how you find out, and that's how you reconcile that against what the camera is showing you here. Here's our +5/3 versus +0. It's obvious once we get to here if you go from here at plus 1/3, that looks like that's the thing, because the red's almost there. But keep going, 2/3, 1/3. So the camera's doing a terrible job of giving us a histogram. It looks like all his red is blown out, and the green and blue are mashed up against there. The problem is that this histogram is from a RAW inside the JPEG, JPEG inside the RAW, and it's got all the settings baked in and white balance baked in, and it's just wrong. It's just misleading. And no camera today gives you a RAW histogram, which is what you need. But once you understand to look for this, plus any blinking highlights, you can actually achieve this very consistently and reliably without blowing out any details. All right, so that's our RawDigger histograms. And moving along, let's just look at the effects of this. We're going to see a bigger patch here in a second, but I've blown up this blue patch so that we can look at, let me click on this, make it a little bigger still for the video. This blue patch is at 0. You can, I hope the video shows this. It's covered with colored, I don't know what to call it. I do know what to call it. It's chroma noise, but you can see there's reddish and greenish crap noise scattered all over this blue. That's not blue. It's blue with a junk all over it. So what happens is we go from 0 to 5/3 stop, more exposure. Bink, look how smooth it gets. Look at all of that color smearing just goes away. Let me change this to an A/B comparison to make it a little, so I can toggle it. So I go from plus 5/3 to 0. Look at the chunkiness you see in that in that blue pattern. The only difference there is the exposure, and you can see the noise level is tremendously higher at the metered exposure versus the optimal exposure. Similarly, we can go at, let's say, the metered exposure, and let's compare it to what we can get with Adobe Camera Raw Enhanced Details. So that's without enhanced details and plus AI Denoise equals 10, sorry. The AI Denoise is the critical piece at a setting of 10. That's without, that's with. Without, with. You can see with AI Denoise, you get a much finer grained, less chunky image that removes all that color modeling crap in there. Now what happens if we both expose it right and we enhance it? Bingo. There's the original. There's one that's exposed right and has used AI Denoise. There's an enormous difference here. You just went from something like an APS-C camera to a medium format sensor quality. Just the difference between this is that large. It's not sharper, but I mean the noise level is tremendously better. Plus, it might not be obvious, but this fine detail also has all kinds of noise and fake, or what's called spurious detail. And when you enhance it with AI Denoise, you get the real detail, and it's better detail. All right, so that's the blue patch. And if we go look at like the whole set of patches here, I'm not going to do this big one because it won't fit, but let's look at a crop of this size, and let's again compare, do an A/B comparison, and let's compare the standard exposure to the better exposure. There's the better standard, better. You can see all the, it's very, there's like a sandy look to this, and it's sandy over here, and it doesn't look smooth in the browns. And as soon as we toggle that, poof, everything looks smooth. And this should look nice and smooth if you look at it in real life. So before, after. Now let's add the enhance in there. Okay, before, after. See how much smoother those patches are? That's noise. And you don't really want that. Now, you might say, well, that's not that much noise, no big deal. But what if but it actually is, because to sharpen that, you can't sharpen as much without also accentuating this noise. And that limits you as to what you can do with the image, limits you to how much you can pull up dark tones and so on. Now let's look at the color channels of that image above. Here we've got the red channel. This is in an RGB image, you have a red and a green and a blue. And so here's our red channel. You notice that it's pretty chunky looking here. There's all kinds of coarse, chunky looking stuff here, all over here too. So let's just to keep it simple, let's do the A/B again, and let's compare it to the right exposure fully enhanced. I mean, my gosh, look at the especially down here at the bottom or in this patch. You look at the difference in the coarse, chunky noise in there, and the better version. It's just night and day. Even just the exposure alone, here we go. That's with standard, metered exposure, optimal exposure. Standard, optimal. Standard, optimal. You can see these blacks have got blacker too, so that's going to pop your colors in your image better. When you have a graying from noise, it makes your colors, especially in the darker tones, look grayed, less pure, less rich. So that's the red channel, and when by the time you're done using AI Denoise with proper exposure, you got coarse versus ultrafine, and you should notice that in this area here, we're not losing any detail. There's a tiny little brightness difference here. There's also a harshness that disappears. It may not be evident in the video, but there's a certain harsh edge effect that's in the underexposed one. Similarly, you have the green channel here, and the blue channel. Just pull up the blue channel. I'll do the same AB thing. So that's blue. That's proper exposure and enhanced. So, and there's without and with. You can see this color. Same effect. It's just these color patches are different patches. It's a big difference. All right. So, what is how do you do this? Well, this plus bit just means on the camera you can add exposure compensation. Plus 5/3 just means that I gave it 1 2/3 stop more exposure compensation as I shot the image. That's all there is to it. You need two tools. You need to use your camera histogram and your RawDigger histogram. You need to get the exposure right. First of all, always get your exposure right if you can. And then Adobe Camera Raw Enhanced Details with AI Denoise equals 10 is a huge winner. It takes your already excellent technical stuff and makes it even better. And if you goofed, it makes it better. So you can't lose with this. I clicked that link there. There's another video screencast here that talks about workflow using enhanced details plus AI Denoise. And this will walk you through how to do that. So to summarize, if you can, always capture the scene, look at it in RawDigger, and then adjust your exposure. You could do that in a studio, for example, so you can actually verify it. But barring that, what you need to do is develop the experience of looking at your camera histogram and then checking it on the computer and seeing how close you got to the optimal exposure. And the easiest way to just bypass the complexity is bracket. So you might say bracket at metered exposure, maybe plus 2/3 and plus 4/3. That's a little conservative because you might be able to go more, even 2 stops. But 4/3 will give you a considerably better image than the metered at plus 0 in a lot of scenes. So study that, compare it on your camera to what you see with RawDigger, and you are essentially giving yourself an enormous camera upgrade. All right, and that's about it, I think. Pay attention to that histogram. Oh, by the way, configure this histogram to RGB. It's no good configuring it to just luminance because you need to see these color channels and you need to see these blinkies too. All right, so please see my webpage at Digloid Making Sharp Images. That's where this page is, and this video is in reference to that page.